How many people are lucky enough to say that they've been to outer space? Maybe sometime in the future, space travel will be much more common. As we keep developing technology, we may soon be launching astronauts to missions on other planets, sending travelers out for deep space exploration, or even running commercial flights for space tourists. For now, though, only a few exceptional people are selected for space missions. And today, we're lucky enough to chat with one of them. Hi, I'm Taylor from WOW STEM, and today I'm talking with former NASA astronaut Ellen Ochoa. Dr. Ochoa was the first Latina woman in space, and after her career as an astronaut, she became the first director of the Johnson Space Center. Dr. Ochoa, it's such an honor to talk to you. Thanks so much for sitting down with us today. So I'm going to start by talking about how someone actually becomes an astronaut. How did you apply?
I wrote to NASA and got an application. And, tried to find out a little bit more about the process. When I first contacted them, I was in the middle of getting a PhD. And so I actually waited probably a couple years or so till I finished my PhD. And then I sent in my application.
What was that interview process like after the application?
So NASA, of course, doesn't select astronauts every year. They just, every year they look at sort of, how many they have, what the flight manifest looks like going forward, and then they decide when they're going to do it. So I guess a couple years after I sent it in, when they decided to do a selection. And I was lucky enough to be one of the people that they invited down for an interview. And, it probably wasn't until I got there that I realized that only about 120 are invited to interview out of a few thousand applications. So I had already made it through a few layers or levels of the application process, which was exciting to hear about. And then we spent about a week at Johnson Space Center. So we had a chance to, talk to current astronauts, which was really my first chance to talk to someone in the astronaut office. We got tours of the training facilities and of the center. We had many different kinds of medical testing all throughout the week. And then, of course, there was an hour where we had an actual interview with the selection committee.
For the actual process and interviewing, are there restrictions on who can become an astronaut?
Well, of course, you need to have a college degree in some kind of technical field, science or engineering, or, for example, a medical degree. And nowadays, you need to have an advanced degree as well. That wasn't a requirement when I applied, but if you looked at who got selected, almost everybody had an advanced degree anyway. In terms of other things, mostly it's medical that keeps a lot of people just not able to continue, I would say, with the process. If you take any kind of medication that really didn't allow you to continue with the process because people absorb medications differently in microgravity. And so even if you have a condition that's well controlled on Earth, that's not necessarily the same in space. Eyesight kept a lot of people out, although they've expanded what they accept nowadays. At the time, you really had to be 20/20 without any kind of correction. But, if you were healthy and if you had a technical degree, you certainly were eligible to apply.
So what kind of skills do you think are the most important to become an astronaut?
Well, there's a number of different kinds of skills. I mean, obviously, understanding about science and engineering is important because, the first thing you learn about is really all the systems of the spacecraft that you're going to be flying. Of course, in my case, that was the space shuttle. And we were responsible for operating those systems and understanding how they worked, understanding how to get around issues when there were problems with those systems. And then, of course, what we were doing in space was generally related to science or technology experiments. And so having some familiarity with having done that was important as well. But then there's a lot of skills that are just, I would say, important, but in a different kind of way, right? In terms of, I think astronauts need to be both good leaders and good followers. And a lot of people maybe aren't both, or some may not even be either, but a lot of people aren't both, because you take on different roles on a crew, and you may be responsible for a particular activity or role on a crew where you really kind of are the leader. And then in other cases, you're sort of working for other members of the crew. And of course, you're always supporting a much bigger program than what your own crew is working on.
Well, that I think segues greatly into our next section. So we talked a bit about how you got accepted into the astronaut program. You ended up flying 4 different space flights, adding up to, I believe, about 1,000 hours in space. And you mentioned it a little bit, but what were you doing while you were up there in space?
Well, on my first 2 missions, we were part of a program that NASA had at that time called Mission to Planet Earth. So it was about understanding more about our own planet. And these 2 flights were specifically studying the Earth's atmosphere and particularly the problem of the ozone hole and ozone depletion. So we had a number of science instruments on board in our payload bay. We operated them from inside the shuttle, and also scientists on the ground were able to, talk to their instruments and interact with them. So my main role, we were operating 24 hours a day, so we had shifts. So on my shift, I was sort of the main science person, making sure that everything was going correctly with the science instruments collecting data. And then we also had on both those missions science satellites that we needed to use the robotic arm to deploy into space and then to grab and, come back and rendezvous with it a few days later and grab it with the robot arm and berth it back in the payload bay. So I was the primary robotic arm operator on both of those missions. And about the time I came back from my first flight is when they added Russia as a primary partner to their international collaboration, which already included the Europeans, the Canadians, and the Japanese. So I was lucky enough that my 3rd and 4th flights were part of building the International Space Station. One of them was the very first shuttle to dock with the new station. Nobody was living on board yet. We didn't have a habitation module. It just consisted of 2 modules, one American, one Russian. And so our job was to transfer a lot of supplies, both internally and externally, primarily. We had a few secondary science experiments as well. So again, I was the primary arm operator for that. And also on those flights, also responsible for the transfer of equipment from the shuttle to the station. And I was the flight engineer on those 2 flights, which means I work with the commander and pilot during all the dynamic phases of flight, launch, rendezvous, undock, entry. So a lot of time in the simulator, going through all different kinds of scenarios for that.
For this science going on in space, why is it so important to have these kind of scientific missions in space to begin with?
Well, what you're doing in space are research or activities, science activities that you can't do on anywhere on the surface of the Earth. So you're taking advantage of some feature of being in space. It might be the microgravity. It might be being above most of the Earth's atmosphere. Something like that. So certainly for the atmospheric flights, we were taking advantage of being above most of the atmosphere, but using the sun as a light source during sunrises and sunsets to measure constituents in all the different layers of the atmosphere, all the different altitudes, and able to measure many different constituents at once, as well as measuring the amount of light coming from the sun in all different wavelengths. So these instruments needed to be operated, above the surface of the Earth to actually do the job that they were designed to do.
For these missions, what would you say is the hardest part of being in space?
I think part of it, and I'm particularly thinking about the flights that I were on, the short duration shuttle flights, very busy because they're trying to get as much done during the time that you're in space, which is limited. Just sort of the mental concentration that every single thing that you're doing, you're really concentrating hard on to make sure that you are, following the procedures closely, but also looking for anything that doesn't look right in case, something isn't going exactly the way that it needs to do. And knowing that, in some cases, if something goes wrong, you wouldn't be able to complete a major objective of the mission or something like that. So I can just remember, being really tired at the end of the day when I went to bed, and it's not really a physical tired, but it was just a mental exhaustion of kind of focusing, just really carefully on everything that you're doing. And also one of the really, exciting and rewarding parts is all the different things that you get to do and that you get to learn.
What would you say is the silliest part or the most fun part about being in space?
Well, microgravity is just a very different kind of experience than anything that you can do on Earth. So, anything that sort of allows you to do something that you can't do on Earth, I think is fun. I can remember on my first flight, one of my crewmates weighed about twice as much as I did. And, I could balance him on the end of my finger, in space. Since he was weightless. So I remember getting a picture of that and, just kind of doing things with food. One of the things that we did is we had some goldfish crackers. And so we let some water loose in the cabin, which just forms a big ball, and threw some crackers in. So it looked like a kind of an aquarium without any walls. Of course, you still got to drink the water down and then somehow eat the soggy crackers so that they don't get anywhere else in the cabin. But things like that are always, because you just can't do it anywhere else.
Did you take any personal items with you up on these missions?
One of the things I got to take, which was a personal item, but yet it was part of our work, was my flute. I got to take that up on my first flight because one of the secondary activities that we had was to shoot a video about living and working in space that was aimed at kindergartners through second graders, and kind of comparing what a day in space was like to, what they're used to in terms of getting up and getting ready for school and that kind of thing. So we did have one shot of, well, you can still do your hobbies in space. And so I got to play my flute during that. So it went up as part of the payload for that video.
That sounds pretty fun. Having a little bit of music while you're in space.
Yes.
Yeah, so I know we're developing so much new technology and amazing robotics and artificial intelligence. I imagine that it's going to be really important for the future work in space. Do you think that, and I know you already mentioned your expertise is in manned space missions, but do you think that the future of space missions is more in manned space missions or unmanned, or some combination of the two?
Well, I think it's always going to be a combination of the two. And not only, separate missions, one that would be, say, an uncrewed, maybe science mission and another crewed mission, but actually working together. And you can certainly think about working on the surface of the moon. You're going to have astronauts, but you're also going to have rovers. And I think some of them will be mostly autonomous or could be operated from the gateway, which is going to be in orbit around the moon. And that way you don't have the same latency, although it's pretty small from Earth. But you're trying to use anything that's sort of automated or robotic where that works best, and then use people where that works best, and combine the best of both to get as much done as possible. I think both have the capability to inspire people on the ground. And we see that all the time. I do think when people see actually humans do those things, though, I think it helps people set higher goals for themselves. It doesn't necessarily have to be in the space arena, right? It's just that, people can do this. People are doing this. What can I think of challenging myself with doing as well?
Yeah, I think a lot of people watching this may be interested in being a part of NASA or the space industry when they're entering the workforce in 15 or 20 years. What big questions do you think we'll be working on in 20 years, or that you think we may be able to answer with these space missions?
I think there's some basic scientific questions, and then there's more about how can we use space or learn from space to apply to things on Earth. So, some of the big scientific questions are, the ones that we've been talking about for a while. Are we alone? Is there or has there been life elsewhere? First in our solar system, but then also anywhere else in the universe. And I think that would really, change our perception of ourselves and our planet if we found evidence of that. So I think that is probably the biggest question that is out there in terms of space exploration.
Thanks so much for talking with us today. Our conversation has made me so excited about the future for space exploration. I personally don't think I'll ever go to space, but it was such an honor to get to talk to you. And who knows, maybe someone watching this video will follow in your footsteps and make it to outer space themselves.
Well, thank you. It was wonderful talking with you.